Oops. All right, so let's see. Which one were the quiz problems? We did, okay, number 5 was one of the quiz questions, right? So, what was the trick on number 5?
Change the x to -1/2.
Right.
And then
So x minus 3 times x to the -1/2, right? So then that's going to give me x to the 1/2 minus 3x to the -1/2 dx. Okay. So now we can go ahead and integrate that. So that's going to be x to the 3/2 divided by 3/2 minus 3x. When I add 1 to that, I get a positive 1/2. So I'm dividing by 1/2 plus c. C. Okay. So we have 2x to the 3/2 over 3 minus, this becomes 6x to the 1/2 plus c. And we're done. Okay.
I got one.
I didn't forget the C, but I forgot everything else.
I forgot everything.
Okay, was this the other one, number 8?
Yeah.
Okay, so this was an easier one. I thought it was an easier one. So we're going to integrate that so we get 3 sine x. Why is it plus 2?
Because the derivative of cosine is negative sine.
Yes, plus c, and we're done. Okay? Okay, did you have any other questions from the homework?
Can I just see the other one real quick? I didn't
Yes, Ben.
Can you just show the tangent square one?
Okay, let me just pull my thing up here.
I think it's number 13.
Okay. I do drop the lowest quiz grade, yes. Is that what you're asking?
I put your phone up though.
Oh wow.
I just can't. I round up with 13. What? Oh, it's great. Yeah. It's all
Okay. Okay, I'm sorry, Ben. Which one did you ask for?
I think it was 13, which was the tangent squared.
Tangent squared one? So the key here is you've got to know your derivatives, right? So, this is a tricky one. We have to rewrite this because I can't take the derivative of anything and get tangent squared. But I know that tangent squared plus 1 is equal to secant squared. Yes, that's one of our Pythagorean identities. Okay, so and the reason I saw that was I'm thinking in my head, okay, what do I take the derivative of to get tangent squared? Nothing, because what's the derivative of tangent? Secant squared x. Okay, what's the derivative of secant? Don't we have these listed somewhere for you? Hold on a second. In your trig notes on your unit 6 notes that I gave you, right on page 25. Remember, right? Refresh your memory, right? The derivative of tangent is secant squared. The derivative of secant is secant tangent. So when I was looking at this problem, I was like, okay, what do I take the derivative of to get tangent squared? Like, can't think of it. But then I see the plus 1. I'm like, oh, wait, that's one of my identities. If you don't remember all those weird ones, remember I showed you last year cosine squared plus sine squared equals 1. We remember that one, right? So remember the trick? If I divide everything by cosine squared, right, I get 1 plus tangent squared equals secant squared. And then the other one is if I divided everything by sine squared, I get cotangent squared plus 1 equals cosecant squared. So these are the two additional Pythagorean identities, right? So that means I'm going to change this to the integral of secant squared theta d theta. So go back and look at your formulas. What do I take the derivative of to end up with secant squared? Well, there it is right there. That's tangent. So I'm going to, when I integrate secant squared, I get tangent theta plus c, all right? So you have to know these formulas. You have to know these derivatives in order to do the integrals, okay? Other questions from the homework? You want me to write the answers down? Will that be helpful?
On our test, do we have to know like the trick where it's like 5 to the x is 5 to the x over natural or not? Like, do we have to know that part?
Yes. Okay, number 14. Get this to move. Why isn't it moving? There it goes. Okay, so here, taking the integral of cosine, that one's not too bad because that has to be sine, right? Sine x plus, okay, the integral of 5 to the x, that's a to the x. Look at your formulas. Okay, and down here, okay, here you go right here. That's the formula we're talking about. Here's the integral that we're talking about. So it's going to be 5 to the x over the natural log of 5. Okay, so this will be 5 to the x over the natural log of 5 plus c. Okay. Okay, I'm going to write the answers on here just so that you can check it. Let's see. Okay, number 1, we're looking at 1/4 x to the 4th minus 2x plus c. This is 2/5 x to the 5/2 plus 2x squared plus x plus c. I'll zoom back out after I get them all written in there. Okay, this will be 3/5 x to the 5/3 minus x plus c. Number 4, we're going to have negative 1/3x to the 3rd plus c. Number 6, I'm going to get 1/4 y to the 4th plus y to the 3rd plus c. Okay, number 7, 5t plus c. We did 8. Number 9, 3x plus secant x. Plus c. Number 10, we're looking at 2/5 x to the 5/2 minus 2x plus c. Number 11 is negative 5 cosine x minus 3 e to the x plus c. Number 12, 2x to the third plus 3 e to the x plus c. We did 13, we did 14. I signed up to 15, 16, right? Just 14? Okay. Bless you.
Bless
Let
you.
me zoom out. Okay. Do you need me to go over any of these? Okay. We are going to move on. Oh my goodness gracious.
I was just gonna make that color. I was trying to think of the other one. That's what I was like, wait
All right, let's see where we are here. Okay, did that. Okay. All right, so we're on page 26 of your notes. We're gonna look at solving what we call solving differential equations. Okay. And this is just kind of the introductory version of it. Okay. They will get a little more complicated. Okay, solving differential equations. So we're asked to solve the differential equation subject to given conditions. All right. So the equation is f prime of x equals 2x minus 1. So when we talk about solving it, what we're actually doing, okay, I'm going to rewrite this as instead of f prime of x as dy dx equals 2x minus 1. Okay. Now, when we solve a differential equation, we have to separate the variables, put all the y's on one side and all the x's on the other side. So if I multiply by dx on both sides, I'm going to get dy equals 2x minus 1 dx. When I talk about solving this differential equation, I want to end up with y equals something. Okay? So we're going to integrate both sides of this equation. Okay? Now that I have it separated, I have my variables separated, I'm going to go ahead and I'm going to integrate it. So when I take the integral of dy, what am I left with? If it was the integral of 1, what would we be left with? Or y, in this case y. So the integral of dy is equal to y. Okay? The integral of 2x minus 1 dx, that's going to be 2x squared over 2 minus x plus c. Everybody with me? Okay, so obviously these 2's are going to cancel. So it's just x squared minus x plus c. Okay. In order to solve it, I need to know the value of c. So I'm going to use this information to figure out the value of c. Faith, you have a question? You do? Okay. Okay, so we need to figure out the value of c. Well, f of 2 equals 5 means, right, go back to your algebra, that means when x equals 2, y is equal to 5. Right, that's what f of 2 equals 5 means. So we're going to substitute that in. 5 equals 2 squared minus 2 plus c. This is going to enable us to figure out the value of c. So we get 5 equals 4 minus 2 plus c. So 5 equals 2 plus c. Therefore, c equals 3. Now I can go back up here and I can say y equals x squared minus x plus 3. There's my differential equation solved. Okay. Okay, let's do the next one. We're going to rewrite it. Dy dx equals 2 cosine x, which means dy equals 2 cosine x dx. And we're going to integrate both sides. So we get, technically, by the way, technically, over here, when I integrate the dy, this is actually y plus c. But I don't have to have a plus c on both sides. So see, this is y plus c, and then I get 2 sine x plus c. Well, I can combine my constants and just put the constant on one side. Okay, so I don't have to put the c on both sides. So I just leave it as y. Okay. Okay, so now we're going to go back up here and we're going to use this condition that they gave us. So what do I do with that? Okay, so where's everything plug in?
Negative 3 equals 2 sine of pi over 2 plus c.
Good. So we have to know our trigonometry. What's the sine of pi over 2? Okay, remember your unit circle. Pi over 2 is right here. This is the 0.01, and sine is the y value. So that's 1. Oops. I don't know why I wrote plus c, plus 2. That's plus c. Plus c. Okay, so we end up with negative 5 equals c. So my differential equation, I should have written it as f of x in the previous example, I'm sorry, is f of x equals, right, I'm plugging it back in here, 2 sine x minus 5.
That's actually so cool.
Okay. Okay, I'd like you to finish these 4 problems on this page. Okay, so again, we're going to rewrite this as dy dx. So, I mean, I usually skip a step here and you just write dy equals x squared plus x minus 7 dx.
Do we have to like show all the steps? I just go straight to y. Can't you just go like straight to the integral? I have a rough.
I was just about to say that.
You should show at least this much so that you're demonstrating an understanding that you have to separate those variables. Okay. Okay, so now we're going to integrate both sides. So that means we can say y equals x to the third over 3 plus x squared over 2 minus 7x plus c. Okay? Everybody good with that? Okay. So now we're going to go ahead and substitute in our x and y. So 1 equals 27 over 3 plus 9 over 2 minus 14 plus c. And That means C is going to equal.
Minus 21. Yeah, times 3.
Good catch. Just checking you. Good job. Don't trust everything I say.
Don't trust the internet.
Extract the information.
All right. C equals 17 over 2. What's the question, Faith? It doesn't matter. We can, but it doesn't matter. I'm just going to.
I did not get 17.
What did you get?
I got 55 or negative.
Okay. So
But I did all of that up until
1 equals 9 plus 9 halves minus 21. So let's see. That's going to be 9 minus 21 is what? Negative 12. So that's negative 24 over 2 plus 9 over 2, which is negative 15 over 2. Adding that to the other side, I get 1 plus 15 over 2, which gives me 17 over 2.
I got a random 6 from somewhere, and I think that's what threw everything off.
Well, if you got a random 6 from somewhere, that would definitely throw you off.
Can we do decimals instead of
Yes, you can do decimals if you're not rounding the decimal.
Yeah, so I got 8.5.
Yes, you can do that if you're not rounding it. So we're going to rewrite our answer, f of x. Okay, remember, since the original problem was stated as f prime, I'm going to put my answer as f of x, not as y. So it's going to equal 1/3 x to the third plus 1/2 x squared minus 7x plus 17 over 2. So it's the same thing we've been doing, but now we have the extra step of figuring out the value of c. Okay? So, yes,
Okay, so you can write it as like x to the third over 3.
absolutely.
Okay. You just got a 3 instead of 4. I didn't.
Okay, so now letter D, integrating both sides, we get y equals, it's going to be 3x to the third over 3, so that's x to the third, minus 4x squared over 2, so that's minus 2x squared, plus 2x plus c. Okay. So substituting in my x and y, I get negative 4 equals negative 1. Negative 1 squared is 1, so that's going to be minus 2. Minus 2 plus c. So c will equal, let's see, that's negative 5, adding 5 to both sides, c equals 1. So f of x equals x to the third minus 2x squared plus 2x plus 1.
Yes.
Right? Okay. Next one. So we've got dy, oops, it's not dy, dt. Well, it is actually dy, sorry.
No.
It's the same thing.
It's dy equals the square root of t dt.
Oh, goodness.
Okay, integrating both sides. So this is, I'm going to rewrite this, dy equals t to the 1/2 dt. So we get y equals t to the 3/2 divided by 3/2, which means it's going to be 2/3 plus c. So that means 6 is equal to 2 times 9 to the 3/2. Now, if this is a non-calculator section, we've got to be able to do this by hand, okay? Which is fine. Let's see. I'm going to go ahead and rewrite the 9 as 3 squared. Okay. So we multiply exponents, so these exponents here are going to cancel. So we get 6 equals 2 times 3 to the third over 3. Excuse me. And then here, the 3's will reduce. So this makes it a 3 squared. So 6 equals 2 times 3 squared plus c. So we get 6 equals 2 times 9. So that's 18 plus c. So c equals negative 12. So we have to be able to do that type of thing by hand without a calculator. Okay. So my g of t equals 2/3 t to the 3/2 minus 12. Okay. So I didn't have to do any fancy work with my 9 to the 3/2. I just had to know how to simplify that. Okay. So here we have dy equals sine theta d theta. Integrating both sides, we get y equals negative cosine theta, because the derivative of cosine is negative sine, but I have a positive sign, so it has to be negative cosine, plus c. So we get 2 equals negative cosine of 0. What's the cosine of 0? 1. So 2 equals negative 1 plus c. So c equals 3. So we have y equals, I'm sorry, not y. Oops.
Wait,
We have,
you said cosine of 0 is 1, right?
yes.
It would still be y because the other one, g prime of t, that's y.
This is going to be f of theta. F of theta equals negative cosine theta plus 3.
We can't just say that as y.
No, because the original problem is stated like this, we have to state our answer in function form. Okay. Okay, so for homework, you're going to do numbers 15 to 20, right? 15 to 20, and then 21 to 28. These are going to be bonus questions. They will count as bonus points. 21 to 28. Your homework is 15 to 20. Still number section 6.5. Okay. And then for bonus points, you're going to do 21 to 28. Bonus points.
Do you have to do all of them to get bonus points, or can you do some and get partial?
You can do some.
And do they have to be correct? Yes, over the point.
Yes.
I'm just thinking.
Good that you clarified. I didn't realize that required the clarification. Thank you for pointing that out.
Are the bonus for accuracy?
Yes. You only get points if you get it correct. All right. Okay, so we learned today. What did we learn today?
1 plus 1 equals 3.
1 plus 1 equals 3. And 1 equals 2. Don't believe anything you hear or see. Be a skeptic. Okay, what did we actually learn today in calculus?
To find the
Differential equations, which means we're finding the value of c. Yes. Okay.